All right, pre-calc, we're going to start with the intro for a review of topic 3. What you see here is the formula that we used last time to be able to calculate the slope of the function at any point. So we're just going to substitute into that for part A. So if we go ahead and do that, this is how this is going to look. It's going to be the limit as h approaches 0 of, and now I know this is going to look a little bit different than the way I showed you last class. I'm just going to do it all at once. So here, this just means whatever you're inputting, this x plus h, wherever there's an x, you're inputting an x plus h in place of x. So the way that this is going to look is going to be like this. So we're going to have x plus h quantity squared minus 7 times x plus h plus 10. That's the x plus h part. Minus, and this is incredibly important that you remember you are subtracting the whole function, so you need parentheses here. Minus x squared minus 7x plus 10. And then this whole thing is going to be divided by h. So divided by h. Let me get a line here. Oh, that's terrible. You get the idea. This whole thing's divided by h. Our goal is to plug in h is 0. This would be undefined right now. So I'm just going to draw an arrow down here. Technically, you need to write this every step. I'm okay if you do that. As we saw last time, with this x plus h squared, it's going to turn into x squared plus 2hx or 2xh. It doesn't matter which way you write it, plus h squared. Distribute that negative 7 minus 7x minus 7h plus 10. And then you're going to distribute this negative here to all three of these terms. So minus x squared plus 7x minus 10. This is still being divided by h. And there we go. That's better. So we still want to plug in h is 0. We still cannot do that. But now, as I mentioned last class, everything without an h should simplify to 0. So x squared minus x squared minus 7x plus 7x positive 10 negative 10. If that is not the case, the chances are you forgot to distribute this negative because you didn't put the parentheses around the entire function. That's a very common mistake. So what you have here is the three terms that are left all have an h in them. So what we're going to do is we're going to factor out that h. So it's going to be in the numerator h times 2x plus h minus 7. I'm just going to write it this way so I can fit it on the screen, divided by h. Still want to plug in h is 0, but it would be undefined. Those will simplify out. So that's just going to leave you with now 2x plus h minus 7. We can substitute in now this h for 0. And when we do that, we're just going to be left with 2x plus, 2x minus 7. And this is going to represent the derivative. So the derivative is this symbol here. And the derivative finds the slope at any point. So this is equal to 2x minus 7. And if we want the slope at any x value, we could just substitute whatever that x value is into this derivative. So that's the first one on the intro. The second one, take a look at here on the key. If you haven't done so already, go ahead and do both examples. I should have mentioned that before I started this one, but in the second example here, so again, you're plugging in x plus h squared plus 14 times x plus h minus 8 minus the original function. So I just did that first part up here and brought it down. There's that x squared plus 2xh plus h squared plus the 14x plus the 14h minus 8. That whole thing, that's your f of x plus h. this part here, this entire thing is the f of x plus h, minus your original function, divided by h. You distribute, and then what you're noticing is everything without an h is going to simplify to 0. The three terms that are left all have an h. You factor out that h, simplify, simplify, and then you're going to substitute in this h is going to be a 0, and you're going to be left with 2x plus 14 for the derivative, which you see here, 2x plus 14 for the derivative. So that intro is just a recap of what we did last class with finding the slope of the tangent line. So now let's take that a step further as we look at page 2. So I mentioned this notation a little bit. That notation just represents f prime of x. That's how you're going to read that, f prime of x. And it means the derivative of f of x. So what the heck is the derivative? The derivative is this. It returns the slope of f of x at any point in the domain. And what we're going to see here on page 2 is what that actually means. How do you write the equation of the tangent line? And the steps needed to do that. So using your answer from part A on page 1. So we got on part A 2x minus 7. We want to find f prime of 5, of negative 5. So what this is going to look like here is f prime, f prime of negative 5 equals 2 times negative 5. What did I say? Minus 7? Yeah. Minus 7. That should be a negative 5 here. Okay, so that's just going to equal negative 17. So what does that represent? That negative 17, the slope of the tangent line at x equals negative 5 is negative 17. So what does that mean? I'm just going to show you this so you can kind of get a sense. This shows you a function in black, this y equals x squared, and we're not going to do the second derivative. This red line is the tangent line. Obviously, it's a different function, but if we went to say when x is negative 5, you're not going to be able to see that quite as much, so let's go like something like negative 3. You can see this tangent line has a slope of, in this case, negative 5.8. So essentially what we're doing to find this is if we took the equation x squared minus 7x plus 10, plugged it into this graph and looked at the tangent line slope at negative 5, it would be negative 17. Obviously, this isn't that equation, and I can't make it that. All right, write the equation of the tangent line. So this is just going to be following a couple steps, which are listed above. First, we need to figure out what the y-coordinate is. So we're going to just plug in f of negative 5 into the function. We know our x value is negative 5. So this is just going to be negative 5 squared minus 7x. So minus 7 times negative 5. And then I think the constant was plus 10. Yes. Plus 10. So negative 5 squared, that's 25, plus 35 is 60. This is 70. So that's that first step. Find the derivative or the slope for the function at the value. We got that, negative 17. And now here's what we have. We have a point and we have a slope. So we have the point negative 5, negative 17. And we have a slope of 70. Nope, I'm sorry. We have the point negative 5, 70. And a slope of negative 17. So we're going to plug into this point slope form. The y-coordinate goes here, the x-coordinate goes here, and then the slope goes here. So going back down here, this is going to look like y minus 70. That's this y-coordinate here, equals the slope, negative 17, times x minus a negative 5, which we're just going to rewrite as x plus 5. And what this is, this right here is your equation of the tangent line at x equals negative 5. At a different x value, the equation of the tangent line is going to be different. And just visually to show you this, as we change the x value, you can see the red line changing. That would have a positive slope. That would have a negative slope. So the x value dictates what the equation of the tangent line is going to look like. So what I would like for you to do on the second part of page 2, go ahead and answer these two parts here. So pause the video and then come back and take a look. So on the bottom half of page 2, what you should have got when you substitute f prime of 4, the derivative was 2x plus 14. So 2 times 4 plus 14 is 22. What the heck does that mean? That's the slope of the tangent line at x equals 4 is 22. If we want to find the equation, we need to know the y-coordinate when x is 4. You plug that into, notice, the original equation. When you plug that into the original equation here, you're getting 64. That's your y-coordinate. So you have the point 4, 64, and a slope of 22. So y minus the y-coordinate equals the slope, this 22, times x minus the x-coordinate, x minus 4. So this is your tangent line equation at the point x equals 4. In the next video, we'll cover a couple more examples.